Hello, my friends. I'm Clover, and today we're solving Zippee Ki Yay by Philip Newman. So this is the gas puzzle that was originally posted on April 27th, 2024, and this is a killer zipper line Sudoku. And if you've been following the series of puzzles that Philip has been releasing in the gas channel over the course of the last month or so, this probably looks pretty familiar to you, but I'll go over the rules real quick anyways. So we have standard Sudoku rules. So we're placing the digits 1 through 9 once each in each row, each column, and each heavily outlined 3x3 region. Then we also have killer cages, which is something that all of the puzzles in this series by Philip have had in common. So in a killer cage, digits can't repeat, which is moot here because all of our cages are contained within a single column or row. And we also have a small clue in the top left corner of each cage that tells us the sum of the numbers in that cage. So for instance, these three have to sum to 7. Then we also have zipper lines, which is a little bit more esoteric of a variant. So let's go over that one a little bit more slowly. So a zipper line, we have these lines that are of odd length. So for instance, this one is 5 cells long. And to solve with zipper lines, you find the middle cell of that line. So for instance, in this case, it is this cell. And whatever digit goes in that cell is also equal to the sum of every pair of digits that are equally distant from that center cell. So for instance, the sum of this pair that I've just highlighted in blue is equal to orange. And the sum of this pair that I've just highlighted in green is also equal to orange. And that's the case for all of the pairs that have the same distance from the middle along each individual line. So let's get started. So first thing, and this has been a common factor in all of these puzzles, I think they all had this this opening with the 6 and 7 cages. Correct me in the comments if I'm wrong about that, if there were any that kind of strayed away from that. But in the 6 cage, there's only one way to make a sum of 6 with 3 cells that see each other, and that is 1, 2, and 3. 7 cage, there's also only one way to fulfill, and that's 1, 2, and 4. And now we're going to take the fact that we have 1 and 2 here, and we also have 1 and 2 here, and ask ourselves, where do 1 and 2 go in row 3? And the answer is they have to go into these 3 cells. So if 2 of these 3 cells contain 1 and 2, and the sum of all 3 of them is 8 for the killer cage, then those have to be 1, 2, 5. So now let's consider the zipper lines. So this is the center cell on the line. Now this definitely can't be 1 because 1 can't be the sum of any 2 other cells no matter what. So we can rule out 1. We can also rule out 2. 2 technically can be the sum of 2 other cells. It can be a 1 plus 1 as long as they don't see each other. But in this case, we know that whatever this sum is, there have to be at least 2 ways of making it here. We can't just make these both 1s and have 2 1 plus 1 sums. That's broken right off the bat. So this is going to have to be our biggest option, which is 4. So if this is 4, this is 1, 2, or 3. So what do you add to 1, 2, or 3 to make 4? You add, again, either 1, 2, or 3. It's either 1 and 3, 2 and 2, or 1 or 3 and 1. But this digit can't be 1 or 2 because we have 1 and 2 in this region already, so that's a 3. And that makes this a 1, so we can eliminate 1 from there. Now this will either be 1 or 2 because it is whatever you sum together with this 2 or 3 option to make a sum of 4. Now we have a zipper line running through the 8 cage as well. Now this can't be a 1 or a 2 in order for it to be the sum because it's in the center of the line. That must be a 5. So 5 is equal to either 4 plus 1 or 3 plus 2. So these 2 digits are going to be 3 and 4. And because we have a 4 already in row 2, that'll be our 3, that'll be our 4. And so this pair have to sum to 5 by being 3 plus 2. This pair have to sum to 5 by being 4 plus 1. The next place I looked when I was solving this was this 9 cage. So 9 is not completely restricted immediately. There are 3 ways to make a sum of 9 in 3 cells that see each other. One of them is 1, 2, and 6, one is 1, 3, and 5, and the final one is the one that is special because it doesn't have a 1 in it, and that's 2, 3, and 4. 2 of those are ruled out at this point in the solve by having this 3 and 5 in this column already. We can't do 1, 3, 5, and we can't do 2, 3, 4. So this must be 1, 2, 6. And whatever digit lives here is the sum of these 2 cells which see each other. So this can't even be a 2, that must be a 6. 6 is either 1 plus 5, which breaks because we have a 5 in the column, or it is 2 plus 4, which looks like that. So let's just kind of continue moving clockwise around. So In the 24 cage, there's only one way to make 24. That's the absolute biggest sum we can possibly make out of 3 digits, so that's 7, 8, and 9. Now, one fun thing about zipper lines is because the sum of each pair on the line has to be equal to a single digit that's kind of predetermined, we can't ever put a 9 anywhere on the line unless it's in the very middle, because if it was elsewhere, if it was somewhere other than the middle, we'd have to be taking 9 plus something and somehow getting a single digit result, which is impossible. So we can't put a 9 in these cells because they are not in the middle. So that's 7 and 8. Now, this has to be something where we can make a sum that uses a 7, and we can also make a sum that uses an 8. So this must be bigger than 7 and 8. It has to be a 9. Now, 7 plus 2 is 9, and 8 plus 1 is 9. So this is going to be a 1-2 pair. So there's my 1, there's my 2, because we have a 2 in this row already. So that's a 1, that's an 8, and that is a 7. Now this 2 lets us do a bit of Sudoku. So this 2 is going to give us a 1 there and a 2 there, and it shares a region with this, so that's going to make this a 1. So 4 is now 1 plus 3, and that resolves the 6 cage. 23 in 3 cells is always 6, 8, and 9, so we can pencil in that 6 and 8. And now we can use a trick that we've used a couple of times while solving this set of puzzles from Philip. We know that there's a 7 not in any of these 3 cells, and definitely not in these 3 cells, so the 7 goes in one of those. And that rules the 7 out of the 22 cage. So how do we make a total of 22 without using a 7? Well, there are 2 ways to sum to 22. There's either 5, 8, and 9, or 6, 7, and 9. And the 6, 7, 9 option obviously has a 7 in it. So this is going to be 5, 8, and 9. The other way to see this, by the way, is just to observe, and I only just picked up on this a second ago myself, that both of these cages have both 8 and 9 in them. And therefore, the only places we can put 8 and 9 in row 7 are in the 22 cage, and then the third digit is going to have to be a 5 to make a sum of 22. Either way, however you got there. So now, this is the center of the zipper line, so this has to be the biggest of these 3 numbers, so that's a 9. And now 9 is either 5 plus 4 or 8 plus 1, so these 2 cells contain 1 and a 4 to finish these sums. There's a 1 there and there, so that's my 4, that's my 1, and now we pair that up with a 5, and we pair the 1 up with an 8. So now our last cage that we have to deal with is this 21 cage, right? So 21 is not super restricted by itself, but since we know now that there's a 1 in the column, or sorry, we know that there's a 9 in the column, we can go maximal and say, what's 6, 7, and 8 when you take that sum? Well, 6 plus 7 is 13, plus 8 is 21. So that will be 6, 7, and 8. And now there's something really interesting going on at this point with this zipper line, right? So this is the sum of these 2. So first of all, the center digit has to be bigger. And on top of that, there's already a 1 in the column, so it can't just be 1 bigger. It's going to have to be 2 bigger, making that a 6 and 8. That's the biggest we can possibly go. So I think we're going to need to do a little more Sudoku to get anywhere with these final lines. So let's see what we can fill in just using Sudoku. So we have a hidden 5 in region 1 because we have 5s there and there. So that places a 5 in this position. And then we're still going to need a 4, an 8, and a 9 there. So that cannot be our 4 because we have a 4 in the row. Over here, we need 6, 7, 8, and 9. This can't be 6 or 8. In fact, this is also either 7 or 9. These cells can't be 9. These cells can't be 7 because there's a 7 in the row. There's a 9 in the column. In this column, which is nearly complete, we need to place a 3 and a 5, and there's a 5 in region 7 already that takes care of some of that for us. We need to put a 6 in this region as well. And there's a 6 in one of these 2 cells, which rules 6 out of here. So there's our 6. And then we also need a 2 and a 7, which will go that way around, thanks to the 2 up here. Now you're probably screaming at me for this, so I'll go ahead and come back up here and deal with the zipper line. So this is the sum digit. So it can't be smaller than 5 because we can't take like a 4 and make it out of a sum of 5 plus something else. So this has got to be an 8 or a 9, so that's our 4. So 8 is 5 plus 3, which breaks because there's a 3 right there. 9, on the other hand, is 5 plus 4, which is perfect. So that's going to be an 8, and that will resolve all of our marks in region 3, just like that. So let's pencil in what else we have up here. We need 5, 6, and 9 to finish row 1. And to finish row 3, we need 7 and 8, and we can't do either of those yet, so we'll just have to leave them. Let's come down here and take a look at this zipper line. I know from my test solve that we can't do much with this just yet, but I'm going to pencil mark in some stuff here. So we get a 3 and a 5 to finish row 8. And then we have a 4 and a 6 here. There's a 4 and 6 in the columns, so that will be a 6 and that will be a 4. And so 6 is either 3 plus 3 or 5 plus 1, and we can't tell yet without doing more Sudoku first which one of those we're dealing with. So let's hold off on it. To finish this row, we need 3 and 7. To finish this column, we need 6 and 7, and there's a 6 in row 6 already, so there goes our 7. We need a 1, a 3, and a 9 to finish this column, and because we have a 1 and 9 in the row, that's going to be our 3. Now, where should we go next? We need to place a 2 in this region, and there are 2s in these columns already, so there's our 2. This is going to be a 4-5 pair. This can't be a 9 because there's a 9 in the column. So what can we do right here? This column is looking a little bit restricted to me, so we need 1 and 3, and we need 5 and 8. Oh, and funny enough, this is actually a naked 5 that I probably wouldn't have spotted if I didn't start kind of enumerating those options. So we know we only need 1, 3, 5, and 8 to finish the column. And in this row, we already have 1, 3, and 8. So that'll be a 5. That's the only remaining possibility. And that clears all of this up, actually. And then there's our 8 to finish the column. This 1 fixes the 9, 1 pair. These are going to be 2, 3, and 7. So that's not a 3, that's not a 2, that's not a 2 or a 7. So that's all resolved. These cells contain 6 and 7. These cells contain 4 and 8, which is resolved by this 4. And that's actually going to give us, I think, a fair bit of information. Yeah, let's just keep going with that for a little bit. So this 7 will give us a 6 here and a 7. We now have a 5 there, 4 and 5. There's a 3 there. We need a 5 and a 9 to finish this region. That'll be a 6 and a 9, and 8 and 6. And that is how you solve Philip's Zippee Ki Yay. Hope you guys enjoyed that. I really liked that. That was probably one of my favorite installments of this particular series of puzzles, which I've enjoyed, but I'm also looking forward to explaining something other than Killer Sudoku next month. So we'll see what Philip comes up with next. I'll catch you guys next time.